In this video, we are going to talk about an instantaneous rate of change. Basically, an instantaneous rate of change refers to the slope of what we call a tangent line for a particular value of x. Now, some of the questions are just going to ask you to interpret some meanings of some function notation. So you'll notice on this first one, it says interpret the meaning of f of 6 equals negative 158. If you remember back in algebra, for function notation, the 6 represents your x value and the negative 158 represents your y value. So if we look at our choices, the first one says the value of the function evaluated at x equals 6 is negative 158. That would be a true interpretation of that function notation. The second one refers to the instantaneous rate of change. Well, they've not told us anything about the slope of a tangent line, so that cannot be true. The third one talks about the slope of a secant line. Again, they've not given us anything about slope, so that's not true. And then the last one talks about an average rate of change from negative 6 to positive 6. Well, again, they haven't given us any information about x equals negative 6, so that is also not true. All right, on the second one that says interpret the meaning of f prime of 6 is equal to negative 64. Now, when you see that prime symbol, that actually refers to a first derivative. And a first derivative refers to you looking at the instantaneous rate of change. And so basically what this is telling me is that my instantaneous rate of change when x is equal to 6 is negative 64. Or in other words, it's talking about the slope of a tangent line. So that's the same thing as to say the slope of the tangent line at x is equal to 6 is a negative 64. Again, we're not doing anything with secant lines here. If it talked about the height of the function, that would have been where they would have just said f of 6 is negative 64 instead of f prime of 6. And we are also not dealing with average rate of change because they've not told us anything about when x is equal to 0. Now, another type of problem you'll have will be interactive, so I don't have the capability to do the interactive feature of this, but I'm going to kind of show you how it works. So they're asking me to find the slope at x equal negative 3, and so they're looking at the slope at this point right here. And so the way we gauge that slope is that we look at a tangent line that goes through that point, and a tangent line means it's strictly, I didn't do too good of a job drawing it there. It strictly touches that point and doesn't touch any other parts of that graph. So that would be a little bit better. So you're first going to move the point on the curve to where x equals negative 3. So we'll pretend like I moved it there. And then it says plot 2 points. So with your mouse, you will be able to click down. Now, I'll tell you, some of the points will be nice integers and some of them will not. You may get some fractions. But we'll just pretend like, for example, that I see that this particular point right here is on my tangent line, and I see that this one is too. So when you click down, it will give you ordered pairs for those points. So in my case, this would have been negative 2, comma, negative 3 for that point. And then this one would have been at negative 5, comma, negative 8. So it will give you those ordered pairs. And again, don't worry, sometimes it may be fractions. And so once you have plotted your 2 points, then you're going to calculate the slope between those particular points. And so we'll go back to my y2, which is negative 8, minus my y1, which is negative 3, divided by my x2, which is negative 5, minus my x1, which is negative 2. So in this case, minus negative 3 becomes plus positive, so that's negative 5. And then minus negative 2 becomes plus positive, so that's negative 3. A negative 5 divided by negative 3 simplifies to be a positive 5 over 3. So that would be considered the slope of my function when x is equal to negative 3. And it just says write your answer as a simplified fraction, or you can round it to 4 decimal places. So especially if you get some complicated fractions with your ordered pairs, then you can work in decimal as long as you carry 4 decimal places.